Dilations. These are our fun transformations. So dilations are where we're actually going to be changing the dimensions of our figure. So these are going to be a enlargement or a reduction. So our image is going to be getting bigger or smaller. So in our little picture here, our pre-image is this triangle, and it is getting smaller, so it's a reduction to our image. Our dilation, since we are changing the dimensions, is not an isometry transformation. All right, we call how much we are enlarging or reducing, we call that our scale factor. And this indicates how much the figure will enlarge or reduce. And for some reason, our variable for scale factor is K, the letter K. And if K is greater than 1, then that means our pre-image is going to be getting bigger. And it's going to be an enlargement. But if K is smaller than 1, meaning it's a fraction, then we're going to be getting smaller, and that's going to be a reduction. All right, examples, RST, and this K equals, that's our scale factor of 2. Since 2 is bigger than 1, then we know this is going to be an enlargement. Let's 1, 2, 3, 4, 5, 1. 1, 2, 3, 1, 2, 3, 4. And 2, 2, negative 1. Okay, we got our pre-image graphed. It's very light. And we need to make it bigger. So what I'm going to do is I'm going to take my points, both my x and y of the point, and I'm going to multiply each number by the scale factor. So I'm going to take negative 5 times 2. It's going to be negative 10. So that's going to give me the new x value of my r. Then I'm going to take 1 times 2. That's going to give me the new y value. And I'm going to do that for each of these points, which gives me the new vertices of my triangle. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2. This is my new r. Here's my new S. 1, 2, 3, 4. 4. Positive 4. 1, 2, 3, 4. 1, 2. Here's my new T. Here is my new triangle, and it is bigger than that other triangle. So we're going to do the same thing here. We got triangle WXY with these vertices. This time our scale factor is negative. It's 1/4. That is smaller than 1. So it's going to be a reduction, meaning we're going to get smaller. Again, we're going to do the same thing. We're going to take our points and we're going to multiply each number in our point by the scale factor. So negative 4 times 1/4. That gives me negative 1. Now I'm going to take 8 times 1/4, and that gives me 2. So then my new point for W is going to be negative 1, 2. I'm going to do that for each of the points, and I get these points. I'm not going to waste your time graphing those, but this is how you need to know how to get the points. We also can go the other way if we're given the graph of the pre-image and the image. How did I know the difference? Pre-image is just labeled with letters. Image is labeled with letters with the apostrophe. Okay, so how do I tell what kind of dilation this was and what our scale factor was? So I have some steps up here. So you can pick any point on your pre-image and pick a corresponding point. Let's back up. So let's pick a point. Remember we said this one was the pre-image. So let's pick G, and that looks like it is at 1, 2. So this is G. Now pick our corresponding point on our image. So that means G with our apostrophe, 2, 3, 4. 2, 3, 4, 5, 6, 7, 8. So that one is at 4, 8. And then I'm going to set up a ratio that is image over pre-image. So image 4 over pre-image, 4 over 1. Then we're going to reduce the fraction. 4 over 1 reduces to just 4. So our scale factor, or our K here, is 4. This last step says to identify whether it's an enlargement or a reduction. Maybe that should have been first. You can do that at any point. Is this getting bigger or getting smaller? It's getting bigger, so it is an enlargement. Let's look at this second example on scale factor. So it looks like, let's do this first. Is this a reduction or an enlargement? Well, our pre-image is this one here. Our image here, that means it's a reduction. So that means K has to be less than 1. So if we get anything greater than 1, we know we did something wrong. We have our pre-image V at 15.3, our image V at 10.2. So let's put image over pre-image, 10 over 15. And when I reduce that fraction, remember reducing our fraction, we're finding the common multiplier, which is 5. So then that would be 2 over 3. So our scale factor is 2 over 3. All right, let me know if you have any questions on any of the dilation stuff.